Welcome to DC Economics once again. Today I'm going to take you through the new concept in probability, that is bias theorem. Bias theorem, this is a concept that states that the conditional probability of an event based on the occurrence of another event is equal to the likelihood of the second event given the first event multiplied by the probabilities of the first event. So it tends to show the occurrence of the between two events where the first event is equal to likelihood of the second event given the first event multiplied by the probabilities of the first event. Let's assume, for example, we have event 1 and we have event 2 up to the event infinity. Let's say it is event 1, event 2, event 3 up to so forth. So suppose E1, E2 up to EK are mutually exclusive events. The mutually exclusive events, this is a type of a statistical term that is describe two or more events that cannot happen simultaneously. So if the two events cannot happen simultaneously, we tend to apply what is known as union. So suppose the two events will be given as event 1 union 2. So the event 1 union event 2 up to the infinity of a union of a given sample events. So for that case, what you need to understand here, suppose now these union events 1 and 2 are contain all the sample points of the sample of observations. They all contain all the sample data of all the sample of the observation. Then for any event of D, of a given sample data, that is ACE, will be given as a probability of D which is not equals to 0. Will be given at the probability will be given at the probability of PD which is not equals to 0. So Bayes' theorem tend to analyze the conditional probability of an event based on the occurrence of another event. So it tends to show equal likelihood of the second event that are multiplied in relative to the first event as well. So we can generate now the concept for a narration that we have the event 1 and event 2, event 1 union event 2, given on the sample data of the probability that is not equals to 0. So what we develop here, this means that when we take the probability of the first event, event 1, the probability of event 1 given D1, the probability of event 1 given D will be equals to probability of an event will be given as the probability for event 1 intersection D divided by probability of D. This is like to say this will be equals to, when we take out the probability of E1 intersection of D1 over summation. It depends on the type of data set that we are given. We have the summation of I in respect of and the exponential k over there. Then P, we take out the probability of an event intersection D. So from our narration equations like this, from this narration that we have made, now we can develop the general formula that we apply at the Bayes theorem. So this means that the probability of event 1 given D will be equals to, we take out the probability of an event 1, then bracket times probabilities of D given E1. This means that when we take out that function, probability of E1 will be equals to, when we apply the concept of multiplication rule, this means that the probability of event 1 intersection D is equal to probability of D over event 1 times. We take out, this will be given as probability of E1 times probability of D over E event 1, as we observe, divide by. Now, since we have the summations, depending on the how many number of the second data that we have, it may be first data or second data, we develop the probability of event 1 times probability of D given E event 1 bracket plus probability of event 2, depends on how much events you are dealing with to the question. So is equal to probability of event 2 times probability of D given event 2 bracket then plus probabilities of, maybe it could be event 3, depending on the types of events, how many events you are dealing to the question, up to the infinite event. So actually this is a formula that we are developing throughout what is known as the bias theorem. So this is the general formula that we could apply when we are talking about the bias theory. As you can observe. So now let's go quickly to the example. Now it would be better now we go to example so as we can see on how we can solve it. But without forgetting, the bias theorem is also applying the formula, is applying a part of the formula from multiplication rule of probability. I hope remember the multiplication rule states that probability of A intersection B is given by taking the probability of A times probability of A, probability of B given A, as you observe. So that first part on the upper side, as you observe, we apply what is known as multiplication rule to subdivide that equation over there and obtain the general formulas we have. Something like that. So that is what we call the general formula for bias theorem, as you observe. So that is how we apply. Let's go quickly to the question. Let's go quickly to see an example so as we can master on how we can apply the bias theorem in solving different problems. Let's try to check this example over here. For example, number 1, suppose a box contains 2 red balls and one white ball, and the second box contains 2 red balls and 2 white balls. One of the boxes is selected by chance and a ball is drawn from it. If the drawn ball is ready, what is the probability that it comes from the first box? Let us repeat once again. Suppose a box contains 2 red balls and 1 white ball, and the second box contains 2 red balls and 2 white balls. One of the boxes is selected by chance and a ball is drawn from it. If the drawn ball is ready, what is the probability that it came from the first box? So there are 2 boxes and each box was containing some balls. The first box contained 2 red balls and 1 white ball, and the second box contained 2 red balls and 2 white balls, as you can observe. So, and the ball, one of the balls drawn from the such kind of box. Although the question does not indicate on how much was drawn between the 2 boxes, but the red ball, the color of the ball that was drawn was red. So we're required to find the probability that it comes from the first box. Solution. What you need to indicate first, we need to write out A to be the event of drawing a red ball. A to be an event for drawing a red ball, and we let out B to be the event of choosing the first box. So there are two decisions that were made. The first, that is late, we have assumed we have positioned it with A, letter A. Actually, this is the event of drawing a red ball. And B, that is the event of choosing the first box. So if the drawn ball was ready, that's why we position that the first A represents the event of a drawing of a red ball, since it was one of the balls that was drawn without indicating how much number, but it is ready. So you have indicated the event of a red ball to be A, the event of drawing of a red ball to be A, and B to be the event of choosing the first box, since we are required to find out the probability that it comes from the first box, as you can observe. So what you need to understand from our formula, the probability. So in order we can obtain the probability of coming from the first box, given the drawn ball that was ready. So here, what we are finding here, we are finding the probability. The probability, as the question indicates us what to do, we are finding the probability of the first box. We are finding the probability that it comes from the first box, given that the ball that was drawn was ready. So we indicate the probability of coming from the first box given the drawn ball that was ready. This means that the probability of coming from the first box is indicated by B. So it will be probability of B, and that A indicates the event, given the event that was coming from the red ball. So this is like to say it will be the probability of A intersection B divided by the probability of A, as you observe. So this is like to say that the probability of A intersection B, the probability of A intersection B given A is equal. The probability of A intersection B given probability of A is equal to probability of A intersection B. It's like to say we take out, it will be the equals to, it's like to say we take out the probability of A intersection B brackets over A given probability of A is equal to probability of A intersection B. So is equal to taking a probability of A intersection B divided by probability of A intersection B bracket plus probability of A intersection B complement. So the second probability that we have plus is having the complement. So make sure you put out the complement. So we generalize our formula. It's like to say our probability will be equals to probability of A intersection B when you apply the multiplication rule is equal to say we take out the probability of B times probability of A given B. Probability of A given B. So divide by the probability of B times probability of A given B. Since we are dealing with two boxes, so we indicate out probability of again B complement. So is equal to taking probability of B complement, then times probability of A given B complement. So the complements, these are the sets that are not found within, alternative of the sets that are not found. For example, if you want to find the complement of the two sets that there was a head, the answer that was obtained of an event was a head, means that the complement that is main is a tail. That is how we do. We find out the complement. And the complement is given by the formula probability of A is equal to 1 minus probability of B complement. So probability of B complement is equal to taking up 1 minus probability of A. So this is our general form that we could apply now to solve out this kind of question that we have. So what we do here, let me rub the left hand side so as we can have the space of applying our formula. So this is like to say our general formula will be equals to, let me lab over here so as you can have a space. So the main general formula that we are going to apply is like to say it will be equals to probability of B given A. The probabilities of B given A is equal to probability of B is equal to probability of B. We'll open a bracket B is equal to probability. Probability of B1. We take out the probability of B times probability of A given B. So we take out the probability of B times probability of A given B. So this is a general formula that we apply in solving bias theorem. Then we divide by probability of B. We take out probability of B. So indicate out the probability of B, then times probability of A given B. Put out the brackets. We open the bracket, write the probability of A given B, then plus. Since we have the two boxes, we are dealing with the two events. So we take out again probability of B complements, then times. We times out probability of A given B complement, then brackets. So this is the formula. This is what we are going to apply to solve out our question. So what you're supposed to do, let's find what is the probability of B. Remember, in the first box, to the first box we had two red balls. We had two red balls. And we had also one white ball from the first box. So the probability of B is given by taking out. One ball was drawn. The ball that was drawn was red. So we minus one of the red ball from the two red. That will remain out with one red over total number of sample space, that is 2. That we get the probability of B is equal to 1 over 2. So after that we find out the probability of what is known as A given B. So the probability of A given B is like we consider the A was representing representing out the probability from the first box. A was representing the event of the first event of from the first box. So this is like to say that on the first box we had two red and one white ball, as you observe. And from the second box we had two red balls and two white balls. So when you remove one red ball, we remain out is 1 over 2. And from the second box we have two red ball and two white ball. So when we consider to take out a complement, we had one that was not appearing on the second box. So this will give out, when we remove out 1 from the red ball, we remain out with 3, that is given 1 over 2, 1 over 3. So when we remove out 1, this means that on the first box we remain out with 2, and then we divide out by 3 the total number of sample space after the removing of the drawn balls from the first box and second box. So probability of A given B will be equal to 2 over 3, as you observe. So let's find the complement, the B complement. So in order you can find the probability of B complement is where you take out 1 minus probability of B. So when you take out 1 minus probability of B, that we normally consider probability of an complement is equal to 1 minus probability of B. So when you take out 1 minus probability of B, that is a half, what will remain here will remain with a half. So probability of B will be equal to half. So that to say probability of B complement is equal to half. So if you recall back, as I told you, the probability of a complement is given by taking probability of B complement is equal to 1 minus probability of B complement, as observed. So when you take out from our sample data, you obtain the probability of this. This means that you get out the probability of B that is equal to 1 minus probability of B. So probability of A complement is equal to half. So we come and find out the probability of A given beta 1, given B1. So the probability of A given B1 is like to say we consider the event of drawing a red ball from the first box and the event of choosing the first box between the first and the second box. So we come to realize the probability of A given complement is that what is not realized in the first box after the removal of the first box is 1 that was removed. And from the second box, what was not actually realized after the removal of one red ball is 1 that was removed. So those which were removed, those were we term them as the complements. So this means that those which are removed from the first and second box will be equals to 4. So we take out 3 times 4. That is equal to the total probability of A given B complement. So when we return to our formula now, probability of B given A will be equals to probability of B, that is a half, times probability of A given B, that is 2 over 3. Then we divide with probability of B. Probability of B is a half, as you observe over there. Probability of B is a half times we take out probability of A given B, that is equal to 2 over 3. Then we plus probability of B complement, that will be equals to a half. Then we times probability of A given B complement, that is equal to 3 over 4. So the answer of probability of B given A, that is like to say the probability or the probability of coming from the first box given the drawn ball that was ready is equal to, when we make a multiplication of there and make a addition, we obtain the probability of B given A is equal to 4 over 7. This is like to say, we can conclude now, the probability of coming from the first box, given the drawn ball that was ready, is equal to 4 over 7. So that is the answer, is equal to 4 over 7. So that is how we solve simply about biasing theory. Actually, thank you for watching. Don't forget to subscribe my channel, and I welcome you back to DC Economics. Let's call it a day, and I wish you a nice moment. Bye bye.